This is section 1.2. We're going to go over the quotient rule today for exponents. That quotient rule talks about when we're dividing two exponential expressions, like right here in this example, where we have a to the m divided by a to the n. Again, you have to have the same base. Both of them have the base of a. When that happens, you can subtract the exponent, so you get a to the m minus n. There's a couple examples that show you how that works. So here, if you look at this, you have x to the 12th over x to the 4th. So you do x to the 12th minus x to the 4th to get x to the 8th for your answer. The reason that this rule works the way that it does is, say we have x to the 3rd on the top and x on the bottom. If we were to write that out longhand, that would be x times x times x, and that would actually be divided by just the x. Those x's right here would cancel and divide to the number 1, so we'd be left with just x squared on the top. So let's try it ourselves and see what happens. We're going to do x to the 8th divided by x to the 5th. Again, these have the same base. You have x here and x here. So you get to take the base, which is x, and you take the powers and you subtract them. So the power on the top, which is 8, minus the power on the bottom, which is 5. So 8 minus 5 is 3. You get x to the 3rd power. Alright, we're going to try it again here, but it's going to be a little bit harder because we have two bases in this problem right here. But we're still just going to keep the bases separate. So we're going to do these x's together first. So let's take a look at the x's there. We have x to the 3rd on the top, and we're going to subtract the power on the bottom, which is 2. Then we're going to do our y's. We have y to the 4th on the top, and even though there's not a power shown on the y right here, when there's not a power shown, it's the power of 1. So we're going to subtract the power of 1 on the bottom. So the x's would be 3 minus 2, which is 1. I can show the power of 1 there, but I don't have to. And then y to the 4 minus 1, which is 3. So if I were to write this answer out without that power of 1 showing, it would be x, y to the 3rd. Here's another example. This time though, we have some powers here on 3 different bases. So we have k's, m's, and p's. We're going to do our k's first. So we'll have k to the 7 minus 5, m to the 10 minus 3, and p to the 1 minus 1. So k would be to the power of 2, m would be to the power of 7, and 1 minus 1 is a power of 0, which means there's nothing there. That all cancels to just the number 1. So my answer is k to the 2nd, m to the 7th. So here's an example that we're looking at next that actually has some numbers that we need to divide out front. We're just going to let our calculator do the simplification of this fraction right here. So you're going to put 12 over 20 just in your calculator as a fraction and let it reduce it for you. When you do that, it's going to divide a 4 out of both of those because it's divisible by 4. So on the top you're going to get 3, and on the bottom you're going to get 5. So you'll have 3/5. Then you would have, and maybe I should write this a little bit different for right now. Let's just write 3 over 5, and we'll talk about the rest of our variables here. We'll have c to the 4 minus 4, and that just happened just a second ago. When you have the same power up there on the top, it's going to cancel to nothing there, or the number 1 I should say there. And then here you're going to have d to the 3 minus 5. So you're going to have 3/5. So we're going to keep that 3/5 there, so we'll have 3/5. The c's cancel to 1, and then you'd have d to the negative 2. Today I haven't shown you what to do with the negative power, so we're just going to leave it in this form right now. When we talk about the negative power rule in a couple of days, then we'll show you what to do with that, because you really can't leave a negative power there, but for today we're just going to leave it that way. Okay, this next problem right here, 3 to some power over 3 to the 7th power equals 81. So really what that means is I have 3 to a power minus 7 equals 81. 81 would be 3 times 3 times 3 times 3, which would be 3 to the 4th power, just because 3 to the 4th power equals 81. So then I just have to finish solving that. Some power, the question mark right over here, minus 7 equals 3 to the 4th. So that would have to be 11 for the question mark. The question mark equals 11. 11 minus 7 equals 4. So my missing number there is 11. This next one, to just kind of look at them, I have 3 minus 3 on the A's, which is going to cancel to 1. We already decided that 0 minus 0 would be 1, would be, 3 minus 3. I wish that you could just go back like 30 seconds on this and restart.